So I want to tell you about the mathematical journey I went on after my first encounter with the class of problems about connected lights. These are lights connected in a network, and when you flip the switch on one light, you toggle the state of the light itself and its immediate neighbors. So I started with this simple setup of 3 lights in a row, and I wondered if all on-off patterns with these 3 lights were possible if we start with all of them turned off. Then I tried 4 lights in a row. At this point, I was wondering if all patterns were possible if we have a bunch of lights connected in a row, and whether I can prove or disprove it. I decided to start trying by turning off any individual light, since being able to turn it off is the same as being able to turn it on if you just reverse the steps. Now I was stuck. Was there a trick I didn't try? Or was this just not possible? It was then that I stumbled on something curious. There are actually 2 different sets of switches that can turn on all the lights when we have 5 in a row. I know they look similar because of symmetry and all, but those are 2 different sets of switches. If we check the total number of on-off patterns, every light can be either on or off. Each light has 2 states. There are 5 of them, all independent. And the total number of switch sets. Each switch can be included or excluded. There are 5 of them, all independent. The numbers should be equal, 2 to the power of 5. One pattern having 2 switch sets would mean another pattern must have none. Oh, math makes sense again. Now the question becomes, for which number of lights in a row are there patterns that are impossible to make, starting with all lights off? Let me know what you think in the comments below, and until next time, stay curious.